Okay, this is going to be a quick sample problem going over number 2 on 9.3. Specifically, I'm going to do part A, and that is trying to find right here the net force on the positive 3 microcoulomb charge. A couple things before we get going. I'm going to post this work next to it, so if that's easier for you to get like where you possibly made a mistake, feel free to look at that instead. Also, just a heads up, when I originally did this, the document, the negative was weirdly up on the first line, so it was kind of hard to spot that. So if you made that positive, obviously that's also why there's a potential issue on your work. But here we go. So beginning, I'm going to do a force diagram on the positive 3. I can see this negative 6 on the left side is going to be attracting, so I'm going to go that way. I'm going to call that force 3, 6. Okay, the negative 9 on the bottom right is going to go towards it as well. I'll call that force of 9, 6. And this right down here, of course, is also going to pull down. I'm going to call that force of 2.4 dash 6. I use the dash just to separate those numbers out. To find the magnitudes, I'm just going to use Coulomb's law. So force of 3 on 6 is going to be K times positive 3 microcoulombs times negative 6 microcoulombs all over the distance. Now that's in centimeters, so I need to make that 0.15 meters and square it. And I get an answer of 7.2. That should actually be, hold on, I think I screwed that up. Oh, I did. Hold on, labels are screwed up. That should actually say 6.3 right there. I should say 6.3. And these are not even on the right charge. My apologies. So this should be 9.3, and that should be 2.4 dash 3. Sorry about that. So this should be 6.3 there. All right, and that's going to give me 7.2 newtons. Calculating out, and I could see just from the picture that's quick straight to the right, so it's going to be at 0 degrees. Next, going to calculate the next one. That'll be 9.3. And K times positive 3 microcoulombs times negative 9 microcoulombs. All over. Now don't forget that this distance here is not, oops, my apologies. Go back there, I thought I was drawing a line. This distance right here is not 1.5. But I can see from the triangle that that's an equilateral triangle right there. So that should actually be 0. Let's go back to blue. Come on, board. Thank you. 0.15 times the square root of 2 meters. And of course, if you want to just do Pythagorean theorem to get that as well, that should also work. And you should end up with 5.4 newtons. And since it's a square, I know that these are evenly split, so that guy right there should be 45, specifically negative 45. That's negative 45 degrees. Okay. And here we have the force of 2.4 on 3. And that's going to be K times positive 3 microcoulombs times negative 2.4 microcoulombs, all over, once again, going back to 0.15 meters squared. And that should be 2.88 newtons. And you can see that's straight down, so that's at negative 90 degrees. At this point in time, I'm just going to do vector addition. So more than likely your mistake is in here, but if you have those numbers, then your mistake is somewhere inside vector addition. So let's come over here. I'm going to put those up here so that you're just looking at those vectors. Okay, draw a line here and now just do vector addition. I'm going to get all of the x's and all of the y's together while adding them. So I'm going to sum the forces in the x, and that's going to be 7.2 newtons cosine of 0 degrees plus 5.4 newtons cosine of negative 45 degrees plus 2.88 newtons cosine of, I almost ran out of space, negative 90 degrees, but of course cosine of negative 90 is 0, so that's all going to end up as 0. Now I'm going to sum the forces in the y and get 7.2 sine of 0 degrees, but of course sine of 0 is 0, so that should all go to 0, plus 5.4 newtons cosine of negative 45 degrees plus 2.88 newtons sine. Ooh, I said cosine. Glad I got it. Sine. That's right. sine of negative 90. Of course, that's going to get you negative 1 on that. But if I add all of those up, I should get a total x of 11.02 newtons x hat and a total y of negative 6.70 newtons y hat. And that makes sense because that says to the right and that says down. If I go back to my picture real quick, given my 3 initial arrows, kind of makes really good sense that this should go to the right and should go down. Okay, so let's go ahead and finish this bad boy off real quick. Pythagorean theorem to get magnitude. I'm just going to say the sum of forces is equal to the square root of 11.02 newtons x hat squared plus negative 6.70 newtons y hat squared. And that should give me about 12.9 newtons. I think the answer key originally said like 13. And the angle should be the inverse tangent of the y, which is negative 6.70 newtons y hat, over 11.02 newtons x hat. And we get an angle of negative 31.3. I'll say negative 31 degrees. And I should probably check to make sure that angle is correct. Does it make sense that it's in the 4th quadrant? Yes, because that's negative, and that guy up there is positive. So positive x, negative y should be down in the 4th quadrant. There you go.